this video, we're going to talk about the difference between potential and kinetic energy and also look at how to solve each of them individually. So first, let's look at potential energy. So potential energy, by definition, is stored energy. So stored energy. It's energy of position. And so in the example here, where we have an archery class, what this student has done is pulled the bow back. He has done work to the bow. He is storing a certain amount of energy because his work on the bow has given that bow some energy, and now that arrow also possesses that stored energy. The amount of potential energy possessed is equal to the amount of work done. So if he did 100 joules of work to pull this bow back, then the bow and arrow combination would gain 100 joules of potential energy. So for example, you pull a bow back 0.5 meters with a force of 100 newtons. What potential energy does the arrow possess? Well, we said that the potential energy, so potential energy, is equal to the work. Well, work is force times distance. So we can solve for work, and we would then know this amount of work gave that bow this much potential energy. So we did 100 newtons of work, of force on 0.5 meters, and so we get 50 joules of work. So we did 50 joules of work on this bow, so the bow now possesses 50 joules of potential energy. Now, a specific kind of potential energy that we're going to be looking at in this unit is called gravitational potential energy. And this equation, PE equals mgh, is actually still the work equation. So work is force times distance. Well, here, since we're talking about gravitational, we're talking about an object being lifted against gravity. And so the work that is done, the force that you have to apply is equal to the weight of that object. Weight, FW, here you go. So weight times distance. Weight had the equation of mg. That's where this comes from. The force involved is equal to the weight of the object. So mg is the force. The distance vertically has a specific name of height. So force times distance. So in this equation, m is the mass in kilograms, g is the acceleration due to gravity, which again, just like with weight, we're going to use positive 9.8. H is the height, and PE is the potential energy measured in joules. So let's do an example. A 5-kilogram object is lifted 10 meters. How much potential energy does it now possess? So we have our equation, PE equals mgh. So PE equals mass. 5 kilograms is our mass. So 5 times g, which we've known since very early on, is 9.8, times the height, where height is measured in meters. So times 10. So 5 times 9.8 times 10 gives you a potential energy of 490 joules of potential energy. So we did 490 joules of work to lift this object. A 1,000 Newton wrecking ball is lifted to a height of 25 meters. So now this number's in newtons. So newtons does not measure mass. This is the weight. This object has this weight, and we're lifting to a height of 25 meters. So potential energy is mgh, And before, we said that mg is the force. It's the weight. And so we can change this to Fw times h. So 1,000 times 25. So we do 25,000 joules to find potential energy. So how much potential energy does it have? 25,000 joules. How much work was done? Same as potential energy. That's how it gained this potential energy. So 25,000 joules of work was done to give it 25,000 joules of potential energy. So how can you tell if you have to multiply by 9.8 or not? It's the unit. Kilograms is your mass. Newtons is going to be your weight in these types of examples. Or more generally, it's the force. So force is in newtons. So now let's see. If a car is lifted twice as high, how much more potential energy would it have? Well, twice doesn't have a unit. That means this must be a factor question. So we start with our equation. PE equals mgh. We're lifting it twice as high, so we're changing height. And how much more potential energy would it possess? So this is also changing. These two go away. So the change in potential energy is equal to the change in height. So the change in potential energy will be 2. So it'll be twice as much potential energy. The second part here asks what happens if it's twice the mass. So again, we start with the equation. Now mass is changing and the potential energy is changing again. These go away. So our potential energy, the change in potential energy is equal to the change in mass. So the change in potential energy will also double. If mass doubles, potential energy will double. The other type of energy that we need to talk about is kinetic energy. And kinetic, like before, means moving. So kinetic energy is energy of motion. So these objects have to have a velocity. They must be moving in order to have kinetic energy. If they are not moving, they have a velocity of 0, so they have 0 kinetic energy. So here, kinetic energy, our equation is 1/2 mv squared. So if velocity is 0, this entire expression is 0, so it has 0 joules of kinetic energy. So let's just try some examples with this equation now. So we have Ke equals 1/2 mv squared. In this problem, it says calculate the kinetic energy of a 3 kilogram toy car that moves at 4 meters per second. 3 kilograms, kilograms measures mass. Meters per second measures velocity. So Ke equals 1/2. Notice these are units. Each one has a unit, so it's plug and chug. So 1/2 3 times 4 squared. Only velocity is squared. So 4 squared. So if we plug all this into the calculator, 1/2 times 3 times 4 squared, we get 24 joules of kinetic energy. In the next question it says, what if it had twice the velocity? So twice the velocity means there's no unit, so this one is a factor question. So this one's going to be a little interesting, but if we follow the same rules that we always have for factor questions, it will still work just fine. So twice the velocity means that velocity is changing, and we want to know how kinetic energy will change. So these are the only two things changing. Everything else gets crossed out. The half gets crossed out. The m gets crossed out. The reason why the half does, think of that as a constant, right? It's a number, it's a constant, so it does not change. So it goes away as well. So the change in kinetic energy is equal to the change in the velocity squared. So if it's twice the velocity, kinetic energy will be 2 squared, which will give you 4 times. So if you double the velocity, or if it's twice the velocity, you'll get 4 times the kinetic energy. So now what if it's twice the mass? So again, we start with our equation, Ke equals 1/2 mv squared. What's changing now is mass and kinetic energy. Again, the half is not changing. We cross it out. The v squared is not changing, so we cross it out. So Ke, the change in kinetic energy, is equal to the change in mass. So change in kinetic energy is also twice. So if you double mass, it will double the kinetic energy.